How does internal energy change during a chemical reaction? Have you ever wondered what happens to energy during a chemical reaction? It is a fascinating topic that connects to the world around us. Internal energy is the total energy in a system, which includes both kinetic and potential energy at the molecular level. When a chemical reaction occurs, this internal energy changes due to the breaking and forming of chemical bonds. Breaking bonds requires energy input. This means that energy is absorbed from the surroundings to break the bonds in the reactants. On the flip side, when new bonds form in the products, energy is released back into the surroundings. The balance between these two processes determines whether the internal energy of the system increases or decreases. If the energy released from forming new bonds is greater than the energy needed to break the original bonds, the reaction releases energy. This type of reaction is known as an exothermic reaction. In this case, the internal energy of the system decreases because energy is leaving the system and going into the surroundings. Conversely, if more energy is required to break the bonds than is released when new bonds form, the system absorbs energy. This is called an endothermic reaction. Here, the internal energy of the system increases as energy is taken in from the surroundings. To put it simply, the change in internal energy during a chemical reaction can be expressed mathematically. The change in internal energy is equal to the heat added to or removed from the system plus the work done on or by the system. For many reactions, especially those happening at a constant volume, the work done is minimal. Therefore, the change in internal energy closely relates to heat exchange. In reactions occurring at constant pressure, we often use enthalpy change to account for internal energy changes. This includes the work done due to volume changes. Understanding how internal energy changes helps explain why some reactions feel hot or cold. For instance, when you light a match, it feels warm because it is an exothermic reaction releasing energy. On the other hand, when you mix certain chemicals, it can feel cold, indicating an endothermic reaction where energy is absorbed. This knowledge is essential in fields like chemistry, engineering, and environmental science. It helps scientists and engineers control reaction conditions and design energy-efficient processes. By grasping these concepts, we can better appreciate the energy transformations that occur in our everyday lives.